lesson 8.1, graphing f of x equals ax squared, part 1. Okay, so now we're going to look at quadratics, and we're going to specifically look at the things that we need in order to graph them. So, quadratic function. The definition of a quadratic function, that's always going to look like this. Now we're going to look at the ax squared. That just means that there's no constant and there's no x term. Okay, so, and that's fine. That's still considered a quadratic. Okay, and we don't want a to be 0. We need at least that first term to be there. Every quadratic function, if you graph it, it's going to create a U-shaped graph. Right, we talked about that, and that is called a parabola. Okay, all right, so I'm not going to use my graph paper because I want to be able to label everything, so I'm just going to draw a freehand graph. Okay, so if we have the graph of a quadratic, and specifically this one is going to be y equals x squared. Okay, so there's no a term, there's no b term, or there's no a number, I should say. There's no b term and there's no constant. So that means the y-intercept is going to be 0. Okay, if we graphed this, if we plugged a 1 in for x, 1 squared is 1, so there would be a point at 1, 1. If we plugged a 2 in for x, 2 squared is 4. So if x is 2, y is 4. Okay, and then one thing that's really important is that every parabola has an axis of symmetry. And the axis of symmetry is the vertical line that divides the parabola in half. Okay, so an axis of symmetry, the definition of that is the vertical line that divides the parabola in half, and just remember, it will pass through the vertex. And the vertex then is right here. So the vertex is the lowest or highest, if it's an upside down parabola, right? The lowest or highest point on the parabola. Okay, so let's highlight a couple things. So this is going to be your vertex right here. And your axis of symmetry then is going to be a vertical line that divides the parabola in half. So if it's going to pass through the vertex, then the vertical line that passes through the vertex is going to, in this case, is going to be your y-axis, right? Okay, so your axis of symmetry is going to come and it's going to pass through the vertex. And if you look at those words, symmetry, what's that mean? That means it's the same on both sides. So if you think about it, if there's a point 1 away from the axis of symmetry on this side, then there would be a point 1 away on this side. Now, could we put -1 into our equation, yeah, -1 squared is +1, okay? But it's always also good to remember, if you already have 2 points over here, you can just reflect them over the axis of symmetry. So -2 would be a +4, and that one also is just reflected over the line of symmetry, okay? So this is the parent function, y equals x squared. This is what it will look like, okay? All the other ones that we compare to is probably gonna have this as the main base, and then we'll compare the other ones to it. Okay, so those are the two important parts of the parabola that we're gonna look at. And I'm actually gonna flip over because I don't have enough room to draw the next one. Okay, so we're gonna draw one and we're gonna look at all the parts of it. Let's see, I want it to be mostly below. Yeah. Okay, so 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, 1, 2, 3, 4, -1, -2, -3, -4, -5, -6. Okay, so we're gonna figure out what are all the pieces of this. So I'm gonna give you the parabola, and then we're gonna write down all the important parts. So there's gonna be a point here and a point here, and let's see, 1, 2, 3, 4. Okay, so let's draw that. All right, so as you can see, this is not the parent function, right? It would have its vertex at the origin if it was. So where is the vertex of this parabola? It's gonna be the lowest point, right? That point is -1, -4. So that's our vertex, -1, -4. Okay, so we got our vertex right there. All right, the axis of symmetry, remember, is a vertical line that runs through the vertex. So in this case, our axis of symmetry would be right here. It's going to be a vertical line. It has to pass through the vertex. And therefore, because it's a vertical line, think about how we named those, or what the equation of that line was. Every vertical line is designated as x equals, and then whatever it passes through on the x-axis. So the axis of symmetry then would be x equals -1. Okay, and that's how you're going to describe it if they ask you for the axis of symmetry. All right, so that right there is your axis of symmetry. And again, remember we said that means that it would be the same on both sides. So it goes through the vertex, 1 away for both of those points, 2 away for both of those points. So it's always going to be mirrored across the axis of symmetry. All right, what would our y-intercept be? Well, that's easy, right? Just find where it crosses the y-axis. Okay, one thing I do want to note is in the past, lots of people tend to get messed up and think the vertex and the y-intercept are always the same. They're not always the same. Sometimes they are, but not always. So in this case, the y-intercept is 0, -3, not the same as the vertex, right? So be careful of that. And what would our x-intercepts be? Do we have 2 of them? Yeah. Okay, so we have 1, 0 right here. And then we also have negative 3, 0. Now, be careful, okay? We see the axis of symmetry, and some people also make the mistake of thinking that's the y-axis. It's not, so just be really careful when you're counting negative 1, negative 2, negative 3. So that second x-intercept is negative 3. So there's our two x-intercepts. Okay, and let me see if I want to do anything else with that. Oh yeah, okay, so a couple things. Let's do the domain, and I want to remind everybody that the domain means all the x values that would be included in the parabola. Now, notice arrows, right, which means it's going to go on forever and ever to the right and forever and ever to the left. Most parabolas are going to do that. So what would the domain be? The domain would be all real numbers. Okay, that's going to be your answer for domain most of the time for a parabola. You know, if it's a real world problem, then it has more constraints because you wouldn't be able to go on forever and ever, right? But in just general problems, your domain is almost always going to be all real numbers, okay? Goes on forever and ever, left and right. Range are your y values. Now, does it go on forever and ever, up and down? No, okay? Remember, our vertex is either the highest point or the lowest point. In this case, the vertex is the lowest point. So the lowest y value is what you're going to talk about for your range. That means all the y values, if the lowest one is negative 4, then all the y values have to be greater than or equal to negative 4. Okay? If the parabola was upside down, then it would be the highest point, and all the y values would be less than that. But in this case, it's going to be all y values, right, have to be greater than negative 4. All right, back to our old friends, increasing, decreasing. So where is this graph increasing? Well, what's increasing mean? Going up, left to right. Okay, so where does it start going up from left to right? See how it's coming down, and then right here at the vertex, it turns and it starts going up. So it's increasing, and I need you guys to remember, increasing, decreasing, and then negative and positive, all we care about are the x values for those, okay? So when does it start going up? It starts going up when x is greater than negative 1, right? So right here, it turns, and then anything after x being negative 1, anything to the right of that is going to be an increasing on forever and ever. Okay, how about decreasing? So that means going down, left to right. Okay, so we saw it was coming down all the way until it hits there. So it's going to be decreasing for all the x values that are less than negative 1. Okay, all right, let's do positive. What's positive mean? Above the x-axis, right? Good. Above the x-axis. Okay, so where is it above the x-axis? Well, on two different spots. It's above the x-axis on the left side, and it's above the x-axis on the right side. So we would say it's positive anytime x is less than negative 3. So all of the x values below the negative 3, the line of the graph is above the x-axis. And all of the x values when the graph is above or greater than +1. All of those will then be, any x values after 1 will have a y value that's positive. Okay, how about negative? Obviously, that's going to be below the x-axis. And this is going to be an interval because this whole part right here is below the x-axis. So it starts at -3 and up until 1. So anywhere, when x is anywhere between -3 and 1, the graph, the y value of the graph is going to be below the x-axis, or it's going to be a negative number. Okay, and lastly, let's do end behavior. And remember, for end behavior, we always start out with the same thing. Y approaches blank as x approaches -infinity, and y approaches blank as x approaches +infinity. Well, with parabolas, this actually gets a little bit easier because both ends are going to either be going up or both ends are going to be going down. So since both ends go up, then y is approaching +infinity for both conditions, right? So when x is going to the left to -infinity, y is going up to +infinity. When the x values are going to the right to +infinity, the y values are also going up. Okay. All right, I'm gonna have you guys try one. So you're gonna do page 668, number 1. I'll pause it and then check your work. Okay, domain is gonna be all real numbers. The range, you should have gotten y greater than or equal to 1. The vertex was 2, 1. The axis of symmetry was x equals 2. Notice, please, that the x value of the vertex will always be the same as the axis of symmetry because the axis of symmetry has to pass through the vertex. So it's got to be the x value of the vertex. So that's a good way for you to check yourself. Y-intercept was 0, 5, and x-intercept, there wasn't one, right? It didn't hit the x-axis, so there was no x-intercepts for that one. Okay, where is it increasing? It'll be increasing when x is greater than 2. It'll be decreasing when x is less than 2. Let's notice that those are going to just be opposites every single time because for a parabola, it has to change direction at the vertex. So there's only going to be one number where it changes from increasing to decreasing or decreasing to increasing. When is it positive? Now remember, this didn't hit the x-axis, right? So it's above the x-axis all the time. So it's all real numbers is when it's positive. And obviously then it's not going to be negative because it did not go below the x-axis. And lastly, end behavior, when y approaches +infinity as x approaches -infinity, and y approaches +infinity as x approaches +infinity. Okay, again, the ends are always going to go the same way. So these are either both going to be going up and be positive, or they're going to be both going down and these would both be negative. Okay, we're gonna graph g of x equals 2 times x squared, and then we're going to compare it to the parent function, f of x equals x squared. Remember, we said this was the parent function. No a term, no a number, no b term, no c term. So f of x equaling x squared is the parent function. Okay, so what does the parent function look like again? Let's see. Well, remember, its vertex is going to be at 0, 0, right? And then 1, 2, 3, 4. 1, 2, 3, 4. So it's also going to have a point at 1, 1, negative 1, 1, and then 2, 4, and negative 2, 4. Okay, so that's f of x. That's your parent function. So it's always going to look like that. Okay, what would g of x look like though? Let's make a quick table. So we have x, and then we're gonna have g of x this time. We graphed the f of x. So let's just do negative 2, negative 1, 0, 1, 2. If I put negative 2 in for x, so g of negative 2 is going to be 2 times negative 2 squared, which is 2 times 4, which is 8. So negative 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. If I put a negative 1 in to g of x, I get 2 times negative 1 squared, which is 2 times 1, which is 2. So 1, 2, negative 1, 2. If I put a 0 in, I get 0 squared, which is 0. 0 times 2 is 0. Okay, so that's going to have the same vertex. And then we can just, since this is the vertex, the y-axis then is going to be the axis of symmetry. So I'm just going to reflect this over. So the g of x is going to be 1, 2, and then 2, 8. Okay. So the g of x looks very similar, but it's a little bit skinnier, right? Well, what's happening then? If we were going to compare those two, we had our original f of x, so what is the g of x doing? Well, it's thinner because think about what we talked about when we compared them last time, okay? What's getting affected right here? The y is being affected because this 2 is not inside parentheses with the x. Remember that rule. So we always say to ourselves, okay, what's being affected? In this case, the y is being affected. So it has to be a vertical something, right? It's multiplying, so it's not a translation. It's not moving one way or the other. It is stretching or shrinking. So number bigger than 1, that means it's going to be a vertical stretch by a factor of 2. And think about what that means. It's stretching toward the y-axis. So that's why it's skinnier. That's why it's thinner, because it took that f of x and it stretched it towards the y-axis. So it stretches it in and makes it skinnier. Okay, let's just do a couple more comparisons. Get this back in your head because I know you guys, we did this before. So this time we're gonna compare h of x, which is negative 1/3 x squared, to f of x, which is x squared. So again, this is your parent function. We're saying what happened, what did h of x do compared to the parent function. Okay, again, it's not inside parentheses, so it is affecting the y value, right? Not in parentheses. Okay, so it's affecting the y, so it has to be vertical. Vertical something, right? Then we look and see, oh, this one's also multiplying, so it's not a translation, but it is a number between 0 and 1, right? It's a fraction. Okay, don't worry about the negative sign right now. Just look at the number. So it's a number between 0 and 1. So it is a shrink. Okay, so it's vertical, it's a shrink, and it is negative, and that means it's also a reflection in the x-axis. Because it's affecting the y, then it's going to reflect in the x-axis or over the x-axis. Okay, so h of x is, actually let's write the whole thing. H of x equals negative 1/3 x squared is a vertical shrink by a factor of 1/3, and on top of that, a reflection in the x-axis. Okay, so that would be your answer for that one. All right, one more. I want you guys to compare g of x equals negative 2x squared to f of x, which is just x squared. All right, let's just look at it. Well, I'll let you try it. Okay, so not inside parentheses, therefore it's vertical. It's multiplication, therefore it is a stretch or a shrink. 2 is bigger than 1, so it's a stretch by a factor of 2. And it's a reflection because of the negative sign. It's a reflection in the x-axis.